One of the biggest goals of taking organic chemistry is to be able to be a sort of mix between a chef and a magician, to be a molecular chef, and to be able to turn one thing that you have into another thing that you can imagine. Now, that requires you to have learned recipes by heart, to know them forwards and backwards. That's a first step. Once you have them memorized, you can start to do the exercises that begin here. So from this video on, I'm going to assume that you will have already memorized the different reactions for alkynes and also for alkenes. Having those memorized is a first step. Once you have them memorized, you can start to make connections, you can start to notice patterns, you can start to see how one thing can be turned into another. So in this exercise, in 10.11, you have an alkyne, and there are really two things they want you to be able to make. They want you to be able to make an alkene at the top and another alkene at the bottom. And the difference between the two alkenes is whether they are cis or trans. If you sort of draw a line down the long end of the double bond here, you'll notice that those two branches are on the same side of that line. And so those are cis. That's a cis alkene. Whereas if you do the same thing with this bottom one here, draw a line through the long end of the double bond, you'll notice that those branches are on opposite sides of that line. And so that's a trans alkene. So what we have is an alkyne, and we want to turn that into a cis alkene on the top and a trans alkene on the bottom. So what really changes is the bond. We have a triple bond, and that turns into a double bond. Well, what happens when you lose a pi bond? When you lose a pi bond, you do addition. So you can sort of think in those three big categories: substitution, elimination, and addition. And when you lose a pi bond, you do an addition reaction. Well, what did we add? You don't see any halogens here. You don't see any OHs there. Whatever you added seems to be invisible. But it's invisible because it's implied. It's a hydrogen. The only thing that can be there without being drawn in is a hydrogen in these skeletal structures. And so what we added is our two hydrogen atoms, one hydrogen molecule. So we can get hydrogens either from just hydrogen gas or from ammonia if we do dissolving metal reduction. And so at this point you'd say, oh, okay, hydrogen. Alkynes, there are three ways you can hydrogenate a molecule. If you just use hydrogen gas and platinum, palladium, or nickel, you'll go all the way to the alkane. We don't want that here because we have alkenes as both of our possible products. Okay, well, if you just want to do an alkene, to do a cis alkene, you'll want to bubble hydrogen gas through, and you'll want to use a poisoned catalyst like Lindlar's catalyst. To get the trans alkene, you would use dissolving metal reduction, so you'd have solid sodium in liquid ammonia, and the hydrogens will be coming from this ammonia. Now that requires you to remember these reactions, where if you have an alkyne and you treat it with hydrogen gas and Lindlar's catalyst, you get the cis alkene. If you have an alkyne and you treat it with dissolving metal reduction, solid sodium and liquid ammonia, you get the trans alkene. And so that's what they were testing you on here. Okay, let's do this one. So here we have an alkyne again, and the one on top is an alkene. What type of alkene? Cis or trans? Well, we draw a line down the long end of the bond. We see that the branches are coming off of opposite ends, and so that is a trans alkene. So in one of the reactions, we want to turn an alkyne into a trans alkene. Well, we just saw what you need in order to do that is solid sodium and liquid ammonia. Dissolving metal reduction. For B, you have an alkyne and you go all the way to an alkane. An alkane. All single bonds here. Well, that is just the classic hydrogenation. Hydrogen with either platinum, palladium, or nickel. You know, you don't need all three of those. You just need one. But you could write any of those three, and that would be correct. If you just use hydrogen gas with platinum, palladium, or nickel, it'll take you all the way to the alkane. So you just keep adding hydrogen, hydrogen, hydrogen until it's an alkane. So this was just one-step synthesis, but this is going to slowly build on itself and become more complicated, 2 steps, 3 steps, 4 steps. And so you'll want to be able to jump between these structures by recognizing differences in the structure and relating those, associating those to reactions that you have memorized, recipes that you've memorized from this chapter.